How you guys doing? I thought I'd make an introduction to a paper I just translated. The paper is the Formation of Higher Alcohols in Rums. It was published in 1975. This paper was cited by another very important paper called Problems Posed by the Use of Schizosaccharomyces pombe from the same era. And it was from the just incredible French teams at the INRA who were doing astounding work in the era. And I received the paper from Professor Farazmain, who is probably the greatest living rum microbiologist we have today. He's still out there. Every now and then I get lucky and he's willing to reply to an email. I couldn't find this paper and it came from his collection, so we're just incredibly grateful. The paper ends up confirming a lot of practices we've already been using, which is just sort of like the importance of limiting higher alcohols. And it reinforces the idea that is clearly illustrated by the birectifier and some of Arroyo's work, is that the fate of high-value aroma is bound to the fate of fusel oil, higher alcohols. And that if you have surplus higher alcohols, you're in danger of cutting away high-value esters and other things related to rum oil. And that you can't really use any tricks of distillation to overcome it. What you really need to do is go back to your ferment, go back to your yeast selection, go back to every challenging variable and figure out how to limit higher alcohols. And the paper does give some ideas. A lot of these ideas are already in practice. Lalleman has worked out a lot of this stuff and taught the world how to do it, but they still just kind of maximize the potential of budding yeasts. And a lot of it are constrained also by higher temp 48-hour ferments that just absolutely rip. So some of the other untapped ideas are to move to other kinds of yeast strains, and that would be Schizosaccharomyces pombe, that would be Brettanomyces, now that we know how to correct its nutrition and eliminate off aroma, and that might also be the Scandinavian Kvik yeasts, which are a type of budding yeast that is known to work at higher temperatures and also to produce far less fusel oil than the typical budding yeast. But they are, however, known for neutrality. So it's hard to say what the trade-offs will be there. So there's just a lot of ideas. The paper that referenced this one, Problems Posed by the Use of Schizosaccharomyces pombe, also identifies some of the trade-offs with employing them, is that they have a higher lag time where there is definitely risk of bacteria, and that they possibly need to be seeded at a higher rate to overcome that. And that means that some people won't be able to use these until Lalleman offers a product that you can direct pitch, and or people become more skilled at growing yeast in-house, which is daunting, especially when you even need to seed at a higher rate. But one thing that we see, because fission yeasts are such a great avenue to reduce higher alcohols, is that they might become very valuable just for producing lighter styles of rum destined for column stills. They might help give us better mileage from the column still, because we could probably operate them without any fusel oil separation and operate them in a way that just collects more high value aroma. So they might become increasingly valuable, and we're just going to have to learn more about what are the best bet investments. What if we simply add more vat capacity for commodity rums, so that there will be less 48-hour ferments and more things that are 72 hours plus, and possibly even allowing higher temperatures, so the vats will be simpler. They might not have to be jacketed, because we know that fission yeasts also perform at higher temperatures. There just will be trade-offs, and they just open some doors that may or not be useful, but it's only one way to find out.